Welcome to Ask and Learn.
Hi there. In this question, we are trying to calculate the standard enthalpy change for these reactions. So in other words, the standard heat of reaction. And to do that, we need to take the sum of the heat of formation for the products and subtract the sum of the heat of formation of the reactants. So the sum of the products minus the sum of the reactants for each of these equations. And we need to look up these values in Table C. So let's get started with letter A. In letter A, our product is SO3. So looking that up, I see that is negative 395.2. Well, in the balanced equation, we have 2 moles. So we need to multiply this value by 2. And again, that was negative 395.2. And that is kilojoules per mole. All right, and I just multiplied it by 2 moles, so that is going to give me kilojoules in the end. All right, that is my only product. Now I need to subtract the sum of the heat of formation of the reactants. There are 2 moles of SO2. SO2 is negative 296.9. All right, the other reactant is oxygen, but that is in its elemental form. So by definition, its heat of formation is 0. So we do not need to include that here. So calculating this gives me negative 196.6 kilojoules. And that would be my answer for part A. Moving on to part B. We have 2 products there. We have MgO and we have liquid water. So we need to sum up our products here. There is only 1 mole of HgO and 1 H2O in the balanced equation. So we just need to look up their heats of formation. For the MgO, it's 601.8 kilojoules per mole. And for the liquid H2O, it is negative 285.83. All right, those are the products. Now we need to subtract the reactants. There is only 1 reactant, that is the MgOH2. There's only 1 of those. It is negative 924.7 kilojoules per mole. All right, calculating this, we get 37.07 kilojoules. Following significant figures, I would round that to 37.1. All right, let's move on to letter C. In letter C, we have 1 product, that being the water in its gaseous state. The nitrogen is in its elemental form, so it does not have, or its heat of formation is 0. So we do not have to worry about that. But there are 4 of the waters. So I need to multiply 4 times the negative 241.82. And then I'm going to subtract the reactants. Hydrogen, again, is the element, so its heat of formation is 0. So I only need to worry about the N2O4. There is only 1 of those, and it is 9.66. Again, these values are all coming from Table C. All right, the answer is negative 957.62. And finally, letter D. In letter D, we have two products and two reactants that are all going to have heats of formation. So this one's going to be a little bit longer. Starting with the first product, SiO2, it is negative 910.9. And we're going to add that to the other product, HCl, in its gaseous state. There are 4 of those. Notice when you're looking these up, you do have to correspond the state as well. So HCl in its gaseous state is negative 92.30 kilojoules per mole. All right, those are the products. Subtracting the reactants, we have 2 liquid waters, so 2 times negative 285.83, and that's kilojoules per mole. And then we need to add SiCl4, which is a negative 640.1. Okay, that is everything. Now we just need to grab our calculator and calculate our answer here. Calculating all this, we get negative 68.34, but I'm going to round that to just one significant figure since a couple of my values only had one decimal place. Or I'm just going to round it to one decimal place rather, as I look at significant figures. And that would be kilojoules. Right. All right, so those are our standard enthalpy changes for each of these reactions. Thank you for watching.